Hello students, welcome to the Yupp Master School Foundation program. Today we are going to discuss the very important topic regarding to the 7th class students, that is units and measurements, which is very important. Yeah, we would like to take that measurement process in order to represent the physical quantity. You need units, it's very clear. So in the measurement process, we are going to follow the different steps to choose a standard quantity and express its value. Yeah, that is very clear. Let's take that. So measurement of length, if we are going to take that, right? Suppose you have taken that, right? Yeah, the rat is going to catch the food, it's going to be followed by the path. Just you have to see that it's going to be followed, this one, it has been reached that. Here we would like to take that, this is the path. Yeah, we are going to take this one, right? So we are going to take the path followed, just it is going to identify it, path dependent, yes, it has been directed to move in a given path, it's very clear. Now if you are going to take that, sometimes if you are taking that, it's going to be taken as, yeah, does it might finds that shortest path, you have to see that this is the case, we are going to take that. Yes, you are going to take this, it's going to, how it is going to be taken. Here you have to talk about that path dependent, path independent, just we have to take that path independent. So you can take that, this is the displacement, this is the displacement, right? Now it is very clear, you are going to know about this displacement and the distance covered, right? The direction is also very important. In what direction does it reaches? If it has moved with actual path, if it has been moved with the shortest path, so you can get the displacement. If it is going to be path dependent, it is going to have that measurement of the actual distance, right? That's what we can take that. Direction is also very important while you are measuring the physical quantities, right? You have to take this one, right? Let's go for another one. Yes, if it is going to be taken as a plane, yes, it's a plane, you can take that. This is a one plane, right? The motion of a particle is limited to a plane. You have to take that. Particle is limited to a plane, is in the plane. Just it is going to move that in the plane, you have to consider. You need to identify that position of the particle, just you have to take that, it's going to be take that. So you need to take this is the position. Yes, right. So with the two vertex you have to represent, that is of x and y, and you need to get that angle theta. Just you are going to take that the position of a particle and the displacement, they are going to be identified with the vertex angle. Just you have to take, this is a theta is the angle you have to consider. Now if it is going to be taken in 3D, just you have to take that. Yeah, in case of 3D space, you have to take that 3D space. It's very clear, right? Now you are identifying this yeah, just you can take this one. If you are going to take that one light source, this is one light source which is going to be extending, this is a light source. Yes, so the angle, just you have to take that omega. Yes, the angle subtended by this area in the 3D view with respect to the 3D space, you have to take this. Yeah, it can be identified, right? You can take that, this is the area. So you need to get this solid angle. What is the solid angle? It's going to be the angle made by the area with respect to the 3D space, in the view of 3D space. So the angle subtended by this area can be measured with the help of this solid angle. We can take this one. So it is going to be taken as a steradian. Especially you are going to take that light, while you are going to take that light rays. So you have to get this one. This is the light, what we are having, that light. These light rays are going to be entered in different area. Let's assume in the particular area, if you want to measure that, the amount of light rays, the amount of flux, they are going to be measured with the help of this solid angle. It's very clear. Now we are going to take that, its use, we have to identify this. All right, we would like to get this, we can see that, yeah, this is very clear. We are going to take this one. They are going to be taken as the light rays, they are going to be, yes, they are going to be identified that the light rays, they are going to be entered in this area through the phenomena of dispersion. It's very clear. At the time we are going to get that measurement, angle of dispersion. These are all related to the measurement of the physical quantities with respect to the space. Right? Now let's go for another one. It is also useful to identify that. All right. Please see that. Yeah. Yes, you have been imagined that source here, right? That source, it emits the light rays in the region. So the amount of light has been entered in that area that can be identified with this A, right, or is going to be a one parameter which is used to represent that area, which is used to represent that required space or position of that required space. It's very clear. That's what we are going to take this plane angle and solid angle. Here we are going to take that plane angle. Right. Here we are going to take that solid angle. It is very clear. We will get this one. We will get this one. This is regarding to 2D. Yes, this is regarding to 3D space, 3-dimensional. Just we have to take that with respect to X, Y and Z. This is going to be in this, it is going to cover that entire 3D space. Just we have to take this one. All right, let's go for another one. Yeah, plane angle and solid angle or the supplementary quantities in SI system. All right, students, you are going to understand that the motion of a body has been limited to one plane. Plane is nothing but 2D, just you have to, this is a one plane. If one, in this plane, you are going to take that one reference axis, is one particle is going to be revolving in its, if you want to get that displacement and position and all these are going to be identified with respect to the plane angle. You can take that. In case of circular motion, just you have to see that. Right. So these are all the supplementary quantities, that is plane angle and solid angle, right. So whenever there is a need to represent that one physical quantity with respect to the space, whether it is 2-dimensional space or 3-dimensional space, we have to look into the matter of that supplementary quantities. That is a need of plane angle and solid angle. It is very clear, right. So supplementary quantities, that is going to be plane angle and this is the plane angle and solid angle. Its unit is radian, steradian, and the symbols also going to be taken. All right. Now let's go for another one. Yeah, you have to take this one. This is very clear. Yeah, it is going to be identified. Theta is the plane angle. Just R is the radius. S is the arc. It is going to be subtended by that angle. Yeah. Arc subtended by that radius. Just we have to take that S by R. We are going to take this one. Theta is the plane angle. It's going to be taken as the arc. Yeah, theta is that angle, right. So we can take that solid angle. It's going to be in a 3D space. With respect to the 3-dimensional space, we are going to take this one. All right. It's going to be taken as a steradian. So omega, it's going to be solid angle. Just you have to take this one. This is the space. We are going to take that. Here, this is the source. We can take. So this is the representation of the plane angle and solid angle. Let's go for another one. Derived quantities. While you are learning about these derived quantities, yes, you can take that. Yeah, you have to confirm. Derived quantities and measurement. You have to take this derived quantity. Let us assume Force is a derived quantity. Yes, you can take that. You are going to take that the quantity is derived from the fundamental quantities. The quantity is derived from the fundamental physical quantities. Right, they are known as derived quantities. We can take that one example. Right, if you are going to take that force, it's a derived quantity. It's a derived quantity. It depends on mass and acceleration. Very clear. We are going to know about that derived quantities. Some physical quantities are going to be obtained with the help of some fundamental quantities. Just you have to see that. Yeah, you can take that velocity. Yeah, displacement by time. Yes, we can get this one. Right, here we are going to take that it is a derived quantity, it is a fundamental quantity, it is a fundamental quantity. Just we have to take this one. This is a derived quantity. Just we have to take that derived physical quantity. All right, we are going to take that derived physical quantities. They are represented by the fundamental quantities and supplementary quantities also. Now it is very clear, we are going to take that. How they are going to classify, just you can see that. The units of derived quantities are known as derived units. It is very clear, no doubt at all. The physical quantities derived from the fundamental and supplementary physical quantities are called derived quantities. It is very clear. Now you are going to take that. Acceleration is also derived quantity. Just you can take this one. Right. So, now you can take that. Yeah, acceleration. Just it depends on. Yeah, depend on velocity. Yeah, you can take that velocity depend on displacement and time. Just you have to see that. It's very clear. If you want to derive that one derived physical quantity, you have to get that supplementary quantities and fundamental quantity. It is very clear. That's what you want to represent the derived quantities in terms of fundamental quantities. You need to take that their related formulas and the units also. Let's see that. Yeah, if you are going to take that area, right? Area, it depends on two parameters, length and breadth. If you are going to take that, its derived unit is meter square or centimeter square, whatever. If you are going to take that area, right? Right. Suppose you have taken that area, right? So it depend on, say, derived quantity, and you can take that length and breadth also. Just we have to take this one if you are going to get this measurement of that area. So that is, if you are going to take that A and B, just you have to take that A and B, that gives that area. Yeah, it has been represented, it's very clear. Now you are going to take that one circle, it's going to be taken as that one circle. Yeah. You have to take that. Yes, area is going to be taken as the pi r square. It's very clear. Now we are going to take that pi r square, it is the area, just we have to take. It depends on radius of, r is the radius of the circle. Very clear. If you are going to take that volume, you are going to take that volume, you have to identify that, yeah, volume. Very clear. Now you can take that, yes, yeah, this is a 2D plane, yes, you have taken another 2D plane, this is a 2D plane, we have to take that another 2D plane. Just you have to see that this is a 3-dimensional body. So you can take that volume, it depends on the dimensions, that is length. Just you have to take this one. If you are going to measure that, the volume of a regular body or volume of a cube or volume of that object which occupies the space, right, you can get this one at volume, it's equal to L cross B cross H. It's very clear. So their representation is in terms of meter cube or centimeter cube, right. If you are going to take that one cylinder, just you are going to take that volume, yeah, you have taken that, this is the R radius, we are going to take that radius and height of the cylinder. Yes, in this case you can measure that volume, that is volume is equal to area of the top layer, just you have to take that area of top layer just you have to write here, it's better. How you can obtain that volume of that cylinder? Let's see, this area is going to be pi r square, right. Now if you are going to take that multiplication, that is pi r square into h, that gives the volume of cylinder, it's very clear. We are going to know about this one. Please take this representation, and it is clear if you are identifying that the derived quantities and their representation which are merely dependent on fundamental quantities and the supplementary quantities. It is very clear. Here we are going to talk about that fundamental quantities, height and that radius. They are represented by their units and their symbols. Just you can take this one. So you have taken that velocity also, and the speed also, and the force also. right. Now if you are going to take that measurement, yeah, you are going to take that if you are going to take that measurement in system of different system of units are there, that is you can take that CGS system, yeah, you have to take that old system FPS, CGS, MKS and SI. So you are going to take that SI system is the modified form, it's a modified form of that MKS system. Simply you are going to take that. You have different system of measurements is there. In SI system they have included that 7 fundamental quantities. You know very well about that fundamental quantities regarding to mass, length and time. So they may represented in FPS system of unit, that CGS system and MKS system. So in SI system they are going to be following that after 1971 they are following that new system, that is international system of units, international standard system of units. Just we have to see that, yeah, just that is a need of measurement. If you are going to take that, just you can take this one. What is that need? Simple question is there, what is the need of measurement? Right, you have to take that physical properties of matter, you have to estimate the physical properties of matter. While you are talking about that physical properties, you have to take that size, yeah, you are going to take that, and area, volume, yes, they are depending on the shape of that, yes, you can take that, this is very clear. Mechanical properties, you are going to take that mechanical properties, yes, how you have to get that strength. So you are going to get that, know about that force applied on an area, how it will shares that force. Yes, you have to take that electrical properties, you have to identify that voltage, current and capacitance, right, that is very clear. You are going to take that electrical properties, voltage, current and meanwhile you will get that resistance. Yes, if you are going to take that magnetic properties also, yeah, you have to get that magnetic flux, lines of force, just we have to take this, very clear, we have to get this one. If you have taken that one magnet, just we have to take that, how the flux is going to be entered, how it is going to be. You need to know about that measurement process. You have to measure that magnetic flux, that is Weber, you have to get that Weber. We have taken that magnetic flux, that is phi by A, right, you can represent that is Weber per meter square. So this is a very important to realize that what is the need of measurement. All right, that's what I am telling you. You have to, at each and every stage in our daily life activities, we are having that measurement. All right, that's what we would like to know about all these properties in the coming classes very detailedly. So thank you very much, have a nice day for all, right, and you will convey to all your friends about the classes, yes, let them to know to gain the knowledge, right. Thank you.